In this video, I'm going to explain the formula for finding the area of a circle and also the method of doing so. Here is a GeoGebra applet, and you can open it in an app. Okay, so let's start now. You will see a circle on the screen, and here the circumference is highlighted. Okay, and you can straighten it. That means to turn it into a straight line, which should have the same length as the original circumference, which is equal to 2 pi now. I suppose you understand that this is the circumference of the circle, which is the length around the circle. And now we're going to explore the area of this circle. You should know the formula or methods for finding areas of other geometric shapes like rectangles, square, or polygon, or triangles. And they're all shapes with straight line edges. A circle is different because then the shape is surrounded by a curve. And here, however, we can also try to cut it and rearrange it, okay, to make a shape similar to some other familiar shapes that you know. So the way it's doing is like this. You can click the dissect button here. Here we now divide the circle into number of equal parts, and you can see the number of equal parts here. There are 12 parts, and each part is what we call a sector, a circular sector, right? And here now we can go on to rearrange it. Okay, first of all, put it all on one line, and then you can see the two halves colored in different ways, the red one and the blue one. And then let's turn the blue one on top of the red one in order to make a shape similar to a parallelogram, right? So you can have a look now and think about whether you can estimate the area of this shape, which looks like a parallelogram. So what do you need in order to find out the area of this shape if it is a parallelogram? Maybe you can pause for a while and then think about it. Now let's check that. First of all, for this shape, and you may consider this length below as a base of this parallelogram, right? And imagine that it's more or less like a straight line, which is also half of the circumference, this thickened black line here below, okay? And maybe I can draw a line to highlight this. So I can use the plain line here to mark the base. So imagine that this is a straight line, and then it is also half of the circumference of the circle. And at the same time, you can also check the height of this parallelogram, which is equal to r, the original radius of the circle. Okay. So maybe if you wrap it around, then you can see that this is the radius of the circle. So with these two measurements, that means the height here, which is same as r, the radius of circle, and also the base equal to half of the circumference. Right? Then you can estimate the areas of these shapes based on what you know about finding areas of a parallelogram. That means the height times base. Okay, so we can also use and here to mark the part here. Okay, that means this length of cross should be equal to pi times r, which is equal to half of the circumference. Okay, so how good is this estimation? Let's check it. We can go back to restart this animation, but this time we can divide it in the circle into a larger number of parts. For example, 40 equal parts. Each part is still a circular sector, but much thinner. And each carries a smaller arc, right? Which is closer to a straight line as well. So if you rearrange it in a similar way, okay, put half of them, the blue one, on top of the red one, and then feed them together, then you will also have a shape very similar to a parallelogram. Or even you will imagine that it is even close to a rectangle as well, because the each of this sector is so thin, right? However, the base is not changed. Okay, the estimation of the base is still half of the circumference, and then the height is also the same. So we have a better estimation now. By cutting it into greater number of parts, actually you can have a closer and closer estimations of the area, but based on the same formula, pi r times r. That means equal to pi r squared. Right? So using the same method, you can get closer and closer to the area of the circle, right? By estimating it as a parallelogram or as a rectangle. Right? And so you can imagine that you can divide it into a bigger number of smaller equal parts. Okay? So that is the way that we can explain the formula pi r squared, right? That means r times pi r to get the area of the circle. So this is the end of the explanation.